next talk, we will hear about timelock service. Please give a warm welcome to Director of Aragon ZK Research, Alexander Kampa.
Hi.
All right,
Great.
stage is yours. Thank you.
Thank you. So yes, great to be here. It's my first Cosmos conference, and it's in the beautiful city of Prague. So yes, I'm Alexander, but usually people call me Alex, Director of Aragon ZK Research. And I'll be talking to you about a project we're working on, which is called the timelock service. So in a nutshell, this is going to be a public service where people can essentially get key pairs, public-private keys, essentially be able to encrypt data for decryption at a specified moment in the future. And this will be offered for many cryptographic schemes, including most of the elliptic curves that you might be interested in. And we're building this using Gears, which is a Rust implementation of the Cosmos SDK. So a bit about my group, Aragon ZK Research. We're a team of 9 people, 5 PhDs also. I'm not one of them. We're funded by Aragon Association, and as you may have heard, and it's not in Cosmos, in the Ethereum ecosystem, Aragon is a leader in DAOs. What we do? Well, we do research mainly in cryptography and ZK proofs. Right now, our focus is on a private voting research sprint for the Nouns DAO, and I'll tell you a bit more about this later. So we've done we've worked on, over the last sort of year and a half, number of schemes, a lot of them related to voting or e-voting. So we've got OVote, which is a kind of layer 2 roll-up for Ethereum. Then we've developed blind OVote, which adds anonymity to OVote. We've developed a number of schemes, so SNAVs, Butchervote, Schnorrvote. Some of them resulted in actually academic papers being published. More recently, since sort of last November, we've been partnering with Aztec, and maybe some of you will have heard of Aztec. They're quite big in ZK also. So Aztec are developing this language called Noir. Noir is a Rust-like language, and the goal is to allow essentially mainstream developers to, I'd say, reasonably easily and quickly start coding, ZK stuff. Okay. And so we've contributed to Noir in different ways. We implemented a few of the hashes on Noir, Poseidon, SHA-3. We've done the elliptic curve operations in Noir, and right now we're finishing Ethereum storage proofs in Noir. Okay, and we've done a few other things. I mean, just what you do when you do research. There is actually a mathematics seminar that we're running that is sort of public by invitation. So for people who want to learn about elliptic curves and cryptography, okay, we're starting a new round in July. So a bit of a background of this timelock project. Earlier this year, a very prominent, well-known DAO called Nouns DAO issued a kind of competition for private voting. They wanted private voting, and so we partnered with Aztec. We made a proposal, and we were one of the winners of this competition, so to speak, with the goal of producing, private voting on-chain, trustless private voting on Ethereum. Now, I'm not going to go into much detail here, but achieving trustless private voting on Ethereum with minimal off-chain dependency is a hard task. So we're really at the limit of what's technically possible today. So our project consists, I'm just going to go through this very briefly. There's actually 5 modules in this project to achieve what we need to do. It's basically proof generation off-chain. We then on-chain have to have smart contracts that actually verify the actual votes, and then also verify the result of the votes. We need a relayer for the votes, because to have anonymity, you cannot submit the vote from your own address. And we need a ZK registry because for technical reasons, it's something that cannot be done inside the smart contract. So that's why we have 4 modules. And the 5th module that's part of this project is a timelock service. This was a decision. Why did we do this? Because there are different possibilities of counting the votes, but the most open, the most obvious one is ballots. I'm not doing votes. Votes are something a bit different. Ballots are encrypted for as long as the voting period is open, for as long as people vote. And once the voting period is over, well, private key appears in the sky and all the ballots can be decrypted and everyone can see the results. There are other ways of doing this, but this is the one that gives you the most transparency. And that's why we said, well, that's what we want. We want a kind of time-lapse, time-lock cryptography for this. And one way of doing this would be to do is what I call an ad hoc solution. We do it just for our project, right? So what does it mean? A group of trusted parties, before the voting starts, this group of trusted parties, they get some software, they cooperate, they run this, they communicate. They basically do a multi-party computation to generate a public key. Then, during the voting period, the voters generate the votes. They, using this public key, deposit the votes on some blockchain. After the voting period is done, the same trusted parties that cooperated in the beginning have to gather again, cooperate again to publish a secret key. And afterwards, the ballots can be decrypted, and then based on this decryption of ballots, some ZK proof can be generated, the ZK proof can be submitted on chain, etc. This is just for the ballots. If anonymity requires something else, right, it's a separate issue which is solved by ZK proofs of membership in a group. Okay. So this would be the sort of ad hoc solution. What's the downside? Well, first of all, this group of trusted parties has to do their job twice, once before and once after the voting period. If the second after the voting period, if some of these parties are not available, this private key cannot be generated and we cannot decrypt the ballots. Also, the same process has to be done, repeated for every single vote. So if you've got a DAO or some kind of a reason to vote, let's say once a month, you'd have to do this once a month, which is not very convenient. Okay? So our solution is this public time-lock service. Okay, that's the subject of this talk, to say, let's do this, a service where lots of keys will be available at all times for the entire world as a public service, right? So then you don't need any groups, you don't need any multi-party computation. You need a key for like in 3 months' time, 2 weeks' time, 1 year's time. It's there. You don't need to do anything. You just query the blockchain or query some kind of web interface. You just get it. This relies actually, because we could now also say we'll do it ourselves, or maybe a small group of us. But in fact, we said, well, we need this to be a very highly trusted service. So what we're going to do, we're going to use the League of Entropy beacon, right? And we'll talk about this a little bit later, okay? So we will already use for this an existing highly trusted service. We'll just do a value-added layer to that. We'll support many schemes because, well, there's all kinds of curves out there. I mean, some people still use RSA. We'll be supporting just about everything you can think of. That's the goal. And one thing that maybe I won't go much into later, but I just want to mention it now. We want to open up the possibility of public participation. So, for example, let's say you've got a group of 12 nodes, and the 12 nodes cooperate to generate a public key. We can open up this process and have anyone in the world to submit some part of the computation independently and be part of this. And in our scheme, and I'll come back to this later, in our scheme, if only one party of all the parties that participate in this computation, we just need one single honest party for this to be secret and secure. A single party, okay? So that's very strong, a strong guarantee. How far in the future? Well, obviously this is a design question. We thought, well, we'll go 2 years in the future on an hourly basis and daily up to 10 years, right? So this means that you can say, well, for whatever reason, I want some document or some piece of data that want to be encrypted. I want it to be published on, I don't know, 16th of July 2024 at 3 p.m. I know why, but you might have this requirement. You'll find the key for that. Yeah? And of course, then if it's 3 years, you'd have to choose the day. You'd not have the choice of hour anymore. Okay? And of course, you choose also the scheme. So there'll be lots of keys there, but this is all feasible, computationally feasible. Right? And then, okay, we're not right now thinking of supporting quantum resistance schemes, but this may come later. Supported curves, well, these, for example, are those supported by the ArcWorks Rust library, and ArcWorks is also evolving. We're also going to support curves in the OpenSSL library. So now we come to the League of Entropy. So this is what we're using as a random beacon, as the basis for the system. And this is something that's well known. I mean, they have been generating this randomness for a while. And as you can see here, they've got lots of members. The founding members include the Kudelski Security Protocol Labs, Cloudflare, some universities, and they've added a whole bunch of institutions, universities, companies to it, including, of course, the Ethereum Foundation. So these are, I would say, rather trusted entities. And the League of Entropy has 2 beacons. So there's the original beacon, which started in 2019, which produces a kind of chained randomness. And, well, it's been functioning well for almost 4 years now. The problem is that this is not suitable for a timelock service. And luckily, when we started looking at this, well, in March of this year, the League of Entropy launched a new beacon, in addition to its first one, which is an unchained beacon, and this is what we need. So we're like, wow, this is a nice coincidence. And so that's what we'll be using. And as long as a majority of members of the League of Entropy do not collude, this will be secure. So in terms of use cases, I hope that you can already see some of them. Obviously, we've got voting. So we already know another project that's in the voting, in the business of e-voting, who's interested in this, in timelock. I think there will be others, logically. I mean, this is something that makes a lot of sense. So it's a feature for transparency that I would say most e-voting systems will want. Then, of course, you've got something like timed document release, press releases that are embargoed, corporate earnings, right, that need to be published at a given time and that have impact on the stock market price, and you really don't want them to be published before, right? And so instead of having someone waiting for the exact hour to make something public, they can just relax, they can just encrypt it, and it will be decrypted or decryptable at a given point in the future without stress. Any government data that impacts the market, okay? Now, of course, this is not a kind of a magic solution, right? If you need to encrypt something for a time, right, someone needs to have the data. So it's not like someone has the knowledge. But what you can use the service for is also to reduce the number of people who need to know. So you can just keep the number of people who have access to the data very small. You just encrypt it for some time in the future, and then you can just publish your encrypted data on many platforms. You don't care. And you say, hey, just this is the time, and here's the key. Yeah. So that's another use case. Then we've got, well, you can imagine also trustless betting and auctions, all of these. And here, for these use cases, of course, if we were successful with the service and if we get users, people could come to us and say, well, why don't you add keys, not just on an hourly basis, but maybe on a 10-minute basis. That's something we'll consider in the future for these short-term use cases, okay? Escrow, you can imagine putting something in escrow for a certain time. Of course, it won't work in all cases, but it could work for on-chain escrow, okay, where you can have a smart contract that releases funds if you send it, a data that's signed with a proper signature. In research, I think there's some interesting use cases in research, actually, in academic research, because what we're seeing is scientists who do some study and they get some data. And when a scientist gets the data and then starts to analyze it, well, they may find that by tweaking this data slightly, the results will look much better, right? And this has happened, this is happening. If that scientist, and of course the scientist doesn't want to publish his data until later, if that scientist would encrypt this data with a time lock, yeah, and then do his paper, etc., then at some stage, it could be much later, but the data would be decrypted, and then the reviewers or other academics could verify that the data he used wasn't tampered with during the process of writing the paper. Okay, things like that. Then there are legal purposes that you can also imagine. Again, if a government or some entity needs to publish some data or declassify some data in the future, of course, they don't need this, they can do it themselves, but for purpose of public transparency, it could be nice for them to say, we're already encrypted now, and then it's guaranteed. No one has to do anything, it's guaranteed to be decrypted at a later stage. There's also a use case of dispute resolution that sort of goes into the sort of legal type of use cases. Okay, so the roadmap. What we have now is a sort of experimental chain that's sort of running. And, well, we've got some website that's anyway, just one page, but it's something. So by the end of this month, which is very soon, we will have a test chain running, simply because we have committed. I told you about this private voting project that we're doing for nouns. We've committed to delivering a certain number of things by the end of June, and we will. So it will be a limited sort of functionality prototype, but it will already have the keys there, okay? And then next quarter, it's basically two things. We need more partners. We've got 2 partners right now. I mean, ourselves, Aztec, there's probably Vogdoni, which is this other e-voting project. So we'll need partners, and then we want to launch the testnet, or at least a beta version, right? And then want a production version at the end of the year, at the latest. So I think we're quite confident that this can be achieved, because in a way it's not, all of this is known cryptography. We're not inventing anything. This is not based on some kind of, I mean, there will be probably a small paper, because some of the techniques we use are a little bit nice, let's say, but it's nothing earth-shaking. This is not a huge innovation. We're just implementing stuff. There's a little bit of innovation in one of the schemes, again. So this is something that's feasible. That's why we're confident we can do this. Okay, we can launch this without any problems. So now I just want to take a few minutes to talk about Gears, which is what we're using to do the timelock service, right? So what we're facing was the following. Most of the libraries in cryptography, you have a lot of libraries in C, C++, but more and more is being written in Rust. So Rust is becoming the go-to language for cryptography, right? So that's what we want to use. That's what we're using. And we wanted to create, we need a blockchain. I think maybe that's a question that could have been asked, but it's a question, why do we need a blockchain for this? The key point is that all the data that is used to compute these public keys, this data, it is absolutely essential that this data remains available, that it's not getting deleted. If you delete the data, you cannot uncover the secret key. That's why we need a blockchain. Of course, you could say, well, there's other ways to securely store data, but I think the blockchain is still the most sort of logical, okay? Then we say, well, what do we do it? We can't go to some expensive paid blockchain. we'll just do a Cosmos zone of our own. That sounds reasonable. But then we said, well, it's all in Go, which is fine, but it would be nice if it was in Rust. And we found someone who's actually working on started working on Rust implementation of the Cosmos SDK, or at least of Gaia, and we partnered with them and said, hey, let's do something together. So instead of having our Rust app in the executable running in a backend or running on the same server and the app itself being still a Go app calling Rust, well, if we have Gears, we can integrate all of this. Gears basically is just a library. Gears communicates with Tendermint. Now it's called what? Comet BFT. But it's all nicely wrapped all together. And of course, this Rust app calls all the necessary cryptographic libraries in Rust. So I think, well, we like this solution. And so that's what we're actually using now. And the status of Gears today, it's already usable, at least for our purpose. So where are we? Transaction processing is done. Deserialization, validation, etc. Storage, this IAVL tree, etc. That's done. We've got the bank and auth modules. It has CLI and REST endpoints. And we've got Gaia REST, which is the Rust implementation of Gaia. And I'm not a specialist of this, so some of these words I don't understand, but okay. Anyway, the bottom line is, at this stage already, it works, and it produces the same state hash as the Golang implementation for this reduced set of features. Roadmap, next step is to finish refactoring the code, because initially it wasn't supposed to be an SDK very early, but now it's being refactored to be an SDK. The additional modules will be added pretty soon, staking and ABC. There'll be the ability to add custom modules. Documentation is needed. So bottom line, Gears as it is now, with the limited functionality, is already enough, or just about enough, for what we need for our timelock project. But then, by the end of the year, we'll have lots of more modules, and the system will be production ready for others to use. And in a year's time, we want Gears to be basically completely on the same level as the Go SDK. So that's it. Just a call to action if people want to, well, of course, if you're interested in timelock for whatever use cases. Also, we will be looking for partners and validators. And here, because this is, let's say, I mean, this is cryptography, there needs to be a very high level of trust in the nodes that will be running this network. We will have to be quite selective and probably have to partner with some reasonably well-known names for this to work. But I think together, Aragon and Aztec will be able to attract these names. I'm quite sure of this. OK, well, thank you very much, and happy to answer any questions.